Hey folks, let's have some fun with algebra. Today we're going to look at a real world situation. If you are fortunate to have enough money to buy a new car, new cars are notorious for going down in value very quickly. The minute you drive a new car out of the parking lot of the dealership, it goes down in value drastically. And certainly in the first year of ownership for a new car, a lot of times it's possible that your car can lose 20% in value. In general, the rate that the value of a new car goes down, it tends to go down very quickly when after you first buy it, like the first few years, and then slowly by slowly it goes down less in price. And that type of decrease in value is known as exponential decay. And another way we refer to it is depreciation. In other words, if something goes up in value, we call it appreciating in value. And many things can appreciate in value. Collectors' baseball cards, sometimes older coins, stamps, and antiques. And it turns out that, let's see, what else? Appreciate in value. Sometimes if you put money in the bank, it can appreciate in value. Some things go down in value. If you buy a new car, it's going to go down in value, and we call that depreciation. It turns out that if you ever get yourself in a situation where you own a business and you buy lots of equipment to run your business, you will talk to your tax accountant about depreciating the value of all the stuff that you bought, all the equipment you bought. And what happens is that the government knows that the more you use equipment, the eventually it'll wear down and you'll need to replace it. And so you can use depreciation on equipment as a tax expense, and therefore it saves you a little bit of money on taxes. So let's get back to this for now. So you want to buy a new car. You get to choose the make and model. So take a moment, pause the video, and just dream. The only thing is I'm limiting you to buying a new car for $27,500. I apologize. But it is well known that cars depreciate in value the minute you drive them home. They tend to drop a lot in the first few years and then less over time. We're going to assume a 13% decrease in value annually. That means that we assume that it'll drop 13% in value each year. When you are going to buy this car this year, 2020, I'd like you to estimate what the car's value will be in 2026 and 2030. Now, last lesson that we had, we talked about exponential functions in general, and we talked about what they look like for exponential growth and exponential decay. This is what a function looks like for exponential growth. We say a times the initial amount times 1 plus whatever the growth rate is. That's supposed to be an r. And then we raise that to the power of the number of years or number of minutes or number of months or whatever the unit of time is. That's growth. Okay. Today we're not doing growth. And this week we're going to focus on decay. So what is the equation for decay? Well, it looks like this. Y equals A times 1 minus whatever the depreciation rate is, raised to the power of t, whatever the unit of time is that we say for this problem. Again, this is known as decay instead of growth. Both of these guys are exponential. Okay, they're both considered exponential. One is growth, one is decay. So for the growth, if you had a growth rate of 25%, you would say 1 plus 0.25, and that gets you 1.25. For decay, we would say 1 minus, in this case, 13%, so it'd be 1 minus 0.13. So here we'll have a number that is less than 1. Okay, this will always be less than 1. And for growth, we're always going to have a number that is greater than 1. This guy's always going to be greater than 1. Okay, I'm going to go ahead and get rid of that one up there because it might just confuse you if you're taking notes. Maybe this one might confuse you as well. Okay, so let's get down to the math. So the first thing we're going to do is, what is the model for this this car and its depreciation? Again, the key word here is depreciate. Okay, so the model, let's start with that, based on last lesson's notes. The model will look something like this. It'll be y equals, we said that this A is the original amount, and the original amount here is 27,500. And then because this is decay, we'll do 1 minus whatever the depreciation rate is. In this case, 13%. And we have to write that as a decimal. I would love for you to pause this video and see if you can write 13% as a decimal correctly. Okay, I hope that you tried it, because I'm going to tell you what it is. I believe it should be 0.13 or 0.13. And then we'll raise that to the power of t. That could be an x as well, but for now we're going to do it as time, so we'll call it t. And this is the model. It's called a model because it doesn't tell us what the value of the car will be at any particular moment in time. It simply tells us how to find what the value of a car will be. And again, if you've been listening to the news about the coronavirus crisis, one of the things you may have heard them talk about is mathematical models. And what mathematicians are trying to do every day is they're working on models that help us to better predict how many people will have coronavirus and how many people will die from coronavirus. And after they establish a model, they can then try to determine how many hospital beds they're going to need, how many ventilators they're going to make, et cetera, et cetera, et cetera. So in our case, we just want to know at some point in time, what will the value of the car be? And this is the first step. We establish the model. Now I'm going to go ahead and box that because that is the first part of the answer to this question. I'm going to give you a problem like this, and you're going to have to try to get the answer. Let's go ahead and look at what is the next thing. The next thing is, we're asked, what will the car's value be in 2026 and 2030? Well, we're buying in 2020, so what we're really asking is the value of the car in 2026. This guy will be based on the fact that the car will be 6 years old. In other words, with this, we can say that t must equal 6. And with that, we can then calculate y. So we go and we say y equals 27,500 times 1 minus 0.13. I believe that is 0.87. And then raise that to the power of 6, and then we'll get the answer. Let's see here. I will go and let me do a quick calculation. I'd like you to try the calculation before you see what I do, just to check and make sure you're using the calculator properly. And if you get the wrong answer, I'm going to try to explain the better way. So pause the video, see what you can do. All right, before I show you the math that I came up with, one thing that I'd like you to see is, or I'd like you to think about, is, do you expect the result to be bigger than 2750 or smaller? In other words, regardless of what you see on your calculator, regardless of what you got, what's your expectation? Should we get a number that's bigger than 27,500 or smaller? I hope that you're saying that we should get a smaller number, okay? And if you didn't, that's one quick way to check and see whether maybe you punched the wrong things on the calculator. One trick that I use for problems like this is I try to use PEMDAS myself. Calculators will use PEMDAS, but sometimes if you just type the thing in the way you see it, sometimes the calculator will do PEMDAS in a way that you don't expect it to. I'm going to raise 0.87 to the power of 6 first, then I'm going to multiply by 27,500. I do it in 2 separate steps on the calculator, and when I did that, I ended up with 11,924. And in this case, I got lucky. Rounding to the cents is going to be easy. It's just 72 cents. Okay, so it looks like it's going to go down from $27,500 to $11,924. Now, if that shocks you, well, welcome to my world, friends. This is what happens when you buy a new car. They go down in value pretty drastically. Now, some cars hold their value better than other cars, but on average, you can expect something like this, about a 13% decrease in value annually. Okay, we also want to find out 2030. I would love it if you could do the math on that one. So why don't you pause the video and see if you can set it up and get the answer, and then I'm going to show you what I think. Okay, people, I am hopeful that you set something up that looks like this: 27,500 times 0.87 raised to the power of 10. I'm hopeful that after you punched it into your calculator, you got something like $6,831. I am hopeful that you find it as fascinating as I do that this car that you bought 10 years ago for $27,000 could only be worth $6,800 today after 10 years. And again, here's what it looks like on my calculator. I got it. I rounded to 64 cents, and I hope that you did as well. Okay, so that is what exponential decay problems are all about. I told you that exponential decay happens in all kinds of things, and it turns out that exponential decay is an important part of understanding how you and I process drugs in our system. And not just drugs, but other things like alcohol. So for instance, if you go to get a driver's license, they usually give you a chart that says, it tells you how many drinks that you can have to remain under the legal limit, depending on whether you're a male or a female and how much time has passed. The reason why they tell you how much time has passed is because alcohol leaves the system at a sort of exponential rate. It's exponential decay. And the same is true when you just take something for a headache, like aspirin or Tylenol or Advil or ibuprofen, whatever you want to call it. Those guys leave the system at an exponential rate. So I'm going to give you a problem that involves figuring out how much of a particular drug has left your system. Let's take a look and see what I got for you. Okay, so here is your homework problem. Your one homework problem that you need to do this week. You simply have to, you might have to revisit last week's video that explains how to do this stuff, but hopefully what I just showed you will be enough. And then what you're going to do is you're going to read through this problem description. You're going to figure out what the model is for this situation. You're going to write it out for me. And then you're going to do the calculations for part 3 and part 4. And you're going to write them out, you're going to take a picture, and you're going to attach it to this Google Classroom for this assignment. That's all I got for you. Enjoy. Let me know if you have any questions. Hopefully you know how to get in touch with me by Remind or by Google Classroom private message or by email. Good luck.